In chapter 12, we're going to be talking about analytic geometry. Now that is where we discuss conic sections. The reason that it's called conic sections is because we take a cone. Here we have two cones, point to point. We're going to take two cones and kind of cut them. So whenever you talk about an ellipse, you don't really need both cones, but you get the idea when we move to the hyperbola. So if we take a sheet of paper and just slide it into that cone, this shape that we get right here, this is called an ellipse. And then in the next section, we're going to talk about the hyperbola. It's where we slide a piece of paper in this way and we have this shape. Looks like kind of a parabola, but we have another one as well. And then of course we have the parabola, which is where we kind of slice this at an angle and we get this upside down parabola. Of course, if we slice this one up here, the same way we would get a facing up parabola. Okay, so let's get some definitions. First of all, an ellipse is the set of all points in a plane such that the sum of their distances from two fixed points is a constant, and each fixed point is called a focus, or when you call them together, they are the foci. So in this picture, excuse me, we have this focus, which goes from the center to that point. Okay, so the ellipse is the set of all points in the plane so that the sum of their distances from two fixed points is a constant. So the distance from here to the distance and the distance from here, if you add those together, it's going to be a fixed constant all the way around this shape. There was an example in your textbook. I don't know if I can do this without actually showing you, but imagine you have a pencil at each focus and there's a string connecting those, and the string would be long enough so that if you were to push on it, it would end up on this ellipse here. So you could move that around. So remember, you're still connected to each of these foci. So you can continue to move your pencil around in a circular form and it would make this shape. So that's the definition of an ellipse. The major axis is the longer of the two axes of symmetry. So in this case, we have a horizontal major axis. And of course, the minor axis is in this case, it's the vertical one. It's the shorter of the two axes. The vertices are the endpoints of the major axis, and the co-vertices are the endpoints of the minor axis. And then of course, the center is the center of your ellipse. It's the center of the minor axis and the center of the major axis. We do have the standard form for the equation of an ellipse, and this is where it's centered at 0, 0. You're going to have lots of little formulas, but you can see how they're all kind of related once we get into them a little bit. So this is your general form. X squared over a squared plus y squared over b squared is equal to 1. In this case, a is greater than b. That's very important for when you're going through this, because the length of the major axis is 2a. So your major axis is always under the direction that it's parallel to. I don't know if that makes any sense, but this one would be parallel to the x-axis. Now look at this one. In this case, we switch the a and the b, right? So your major axis is under the y this time. That means it's going to be a vertical, or it's parallel to the y-axis. Okay. The length of the minor axis is 2b in both cases, but notice the b is in a different location. So the length of the minor axis is 2b. The coordinates of the co-vertices are 0 plus or minus b. So you get your co-vertices from this value, and you get your vertices from this value. In both cases, the vertex comes from A, and the co-vertex comes from B. The coordinates of the foci are plus or minus c, in both cases, plus or minus c, but notice one is c0 and one is 0c. That's because if you're looking at these two general pictures, if you have a horizontal major axis, your foci lie on that axis. So we have plus or minus c and 0 for y. But if you have a vertical major axis, then your foci are parallel to the y-axis. In this case, they are the y-axis, or on the y-axis. So you have 0 and then plus or minus c in that case. That's how we get the foci. Okay? So let's look at a quick example. Write the standard form of the equation of the ellipse that has vertices 8, 0 and foci 5, 0. Well, we need to remember our standard form. X squared over something plus y squared over something equals 1. We have to figure out which direction that this ellipse is going. Is it a horizontal one or a vertical one? Notice how the vertices are given as plus or minus 8, 0, and the foci are plus or minus 5, 0. Right? So your y is 0 in all of these cases. If your y is 0, that would be this picture right here. So we're going to have a horizontal major axis. That means our a goes under the x squared. Remember, a is the distance from the center, so plus or minus 8, 0, so that would just be 8. Or negative 8, but if you square it, you're going to end up with the positive. Let's see if I can focus this really fast. Maybe that's a little better. Okay, so what else do we need to know? We need to know what our b is. Well, to get b, we have to find c because we're given the foci in this case. And c squared is equal to b squared minus a squared. That's the formula that we were given up here. C squared is equal to a squared minus b squared. Well, we know that c is going to be 5, right? So we have 5 squared is equal to b squared minus 8 squared. So 25 equals b squared minus 64. I did that backwards. Instead of redoing this video, let's just correct it really fast. Sorry about that. And if you are my student, you know that I make mistakes all the time. Usually I catch them though. Alright, so we have c squared equals a squared minus b squared, not b squared minus a squared. Let's try that again. Okay, so we know a is 8. We don't know b, that's what we're looking for. So we have 64 minus b squared. So we have 25 minus 64. That's going to give us a negative 39 is equal to a negative b squared. Divide both sides by negative 1. B squared is equal to 39. Take the square root of both sides, so b is equal to plus or minus the square root of 39. So that tells us that b is the square root of 39. Well, what is b squared? We just had that right there, right? B squared is 39, and that's what goes into our formula. So we're going to have x squared over 64 plus y squared over 39 is equal to 1.